brought something with me today. It is not a robot. It is not a new AI device. It is not even something that looks impressive on stage. It is just a cup of soil. And I know bringing soil to talk about AI is not the most obvious choice. As is, when most people think about AI, they think about data, algorithms, and screens full of numbers. But this is exactly why I brought this. Because to me, sustainability only became real when it stopped being a word on a poster and became something I could see, touch, and respond to. At school, we often hear important words: biodiversity, food security, land degradation, climate change, and the carbon footprint. These are all important words, yet they are often too big to touch, too big to act on. That is why I decided to find a smaller starting point. Something I could see, something I could measure, and something I could actually improve. But I found that starting point in something that we usually ignore and step on: soil. This became the idea behind my project. Sustainability only becomes real when we can see it, measure it, and act on it. I began thinking about soil in daily life. I often watched my grandmother care for plants, touch the soil, and make the flowers lively when I was a child. She acted based on experience. She did not need a dashboard. She just noticed. However, not everybody has that kind of experience. For students, home gardeners, and community farmers, soil just does not speak in a language most of us understand in. A plant may have yellow leaves, but it might be for a variety of reasons. For instance, if it's lack of water, too acidic, not enough nutrients, or just too much fertilizer. Most of the time, we take a wild guess. And if that guess is way off, the plants die. Sometimes I will look at a plant and feel like the plant was looking back at me like, "Are you sure you know what you're doing?" And most of the time, I was not sure. But the more I learned, the more I realized that soil is not just dirt. It holds water, contains nutrients, supports life, and entire ecosystems. Soil is quiet, but not lifeless. It is full of signals, but just waiting for us to learn how to read them. The issue here is not that people do not know how to read them. The issue is that soil just does not speak in a language most of us understand and can learn from. So I wondered, what if technology could help us translate it? I took this first step at an AI winter camp. My mom took a look at my winter schedule and decided I had too much free time. So she dropped me in an AI winter camp. I did not walk in with a grand mission to save the planet. Instead, I looked like the bedraggled person I was because I was angry that my winter holiday had just been shortened severely. Unexpectedly, this camp changed how I understood technology. I learned that through AI and local platforms, students could actually build working prototypes in minutes. This is exciting, lasted for about 5 minutes. But I quickly realized a prototype can look smart on a screen and still not be useful in the real world. That is why I used simulated data for my first prototype. Soil data for things like moisture, pH, nitrogen, phosphorus, and potassium. But then, stimulated data only helped me with the logic, but it was far not enough. Then, I brought this project to Mr. Liao at STEM office, hoping that he would be impressed. But he was not exactly impressed. He brought up one simple question. If this project only uses simulated soil data, then how can it change problems in the real world? So he suggested that I add soil sensors. At first, I felt discouraged because I had never built a sensor system before. It felt technical, difficult, and way beyond me. But then I discovered something unexpectedly powerful: Taobao. It provided a way to buy a lot of things, like computers, Labubus, and low-cost IoT sensors. This made me quickly realize that connection is not impossible. But of course, it was not as clean as I imagined. I expected it to look like a tiny lab in a plant pot. Instead, it included soil all over the balcony, wires strewn across the floor, and of course, wanting to see if the sensor was actually in the soil. The prototype began on the screen, but the problem lived in the soil. That became SoilSense. SoilSense is an AI-powered app that connects soil data to FAO-based guidance, reads indicators such as phosphorus, nitrogen, potassium, and pH. The goal is not to collect, but to understand the underlying problem behind the soil. Every single plant has its own comfort zone. There is simply no one-size-fits-all solution. Let's take two examples here. Corn, for instance, needs a steady supply of nutrients, but it does not have a high necessity for water. On the other hand, tomatoes cannot survive under extreme water stress, soil pH, and nutrient imbalance. Even under the same reading, this suggests different contexts for different plants, meaning that SoilSense is important here. It connects soil data, crop type, and field guidance into plant-specific care. Not everybody can understand an agricultural report, but many people can understand water less today, fertilize tomorrow, plant seeds the day after the next. SoilSense does not just collect data, but aggregate them into a translated data care. However, I did not only want SoilSense to look good on a screen. That is why I had this tomato test. I divided two groups of tomatoes into two groups. The first one was guided by SoilSense and its recommendations. The second group was based on experience-based care. 4 things were tracked in this case. First of all, plant height, leaf count, stress sign, and overall rigor. At the end of the test, the group that was demonstrated with SoilSense-based care had significantly grown taller, had more leaves, less stress, and overall rigor. However, they did not magically become perfect. The data helped notice problems earlier, reduce guesswork, and make care more precise. It was a small experiment, but this helped us learn that the data does not replace care, merely making it more precise. So, why did this matter? SoilSense connects most directly to 2 SDGs. SDG 15, which is life on land. The prerequisite for healthy plants is healthy soil, and from that branches equal biodiversity and more. Healthy ecosystems are everything. It also connects to SDG 12, which is reasonable consumption and production. If there is less water waste controlled by SoilSense, in addition, there will be less fertilizer waste, meaning that there will not be excess runoff or wasted water. For students, I think a bigger message is this. Sustainability should not only be something you memorize, but should be something you practice and encourage in market decisions you practice every single day. Questions we should ask include, should I water today? Is the soil healthy? And am I wasting resources? This is where the big ideas become real. Throughout this project, I've learned that innovation is not always about inventing something completely new. Sometimes, innovation means connecting things that should have been connected long ago. Experience with AI. FAO guidelines with student action. Data with care. At the beginning, this looked like just a cup of soil. But now, I hope it means something different. It is data, it is life, it is responsibility. This taught me that big problems often hide in small places. And I know. So this means that big problems often hide in small places. AI should not only be used to make our digital lives more convenient, but also be used to foster understanding of the physical world. And for me, the first step is to make the invisible visible. For me, that meant having a handful of soil. Thank you.